Welcome to this lecture tutorial on simulating black hole attack on IoT nodes running RPL protocol. And my name is Faisal Egarwa, and I'm a PhD student who is currently working on this particular RPL protocol. So I'm basically working on the security attacks on the RPL protocol, especially packet dropping attacks, and looking at the ways to address these security attacks. So in this video, we are going to take a look at how to simulate black hole attack on IoT nodes running the RPL protocol. So first of all, to take a look at what is a topology attack, because a black hole attack, as we can see in the figure 1, it falls into what we call a topology attack. So topology attacks is just one category of the security attacks on the RPL protocol. As we can see from this diagram, we have a resource attack, topology attack, and traffic attack. And the purpose of the topology attack is to disturb the topology building mechanism of the network. And this will cause isolation of one or more nodes in the network. So the aim of the isolation attack under topology attack is to isolate one of the nodes from the one or multiple nodes from the network. And topology attack is divided into two classes. We have sub-optimization, as we can see in the particular diagram. Sub-optimization, and in the sub-optimization, it means that the network under attack will converge to a non-optimal form, which will cause poor communication performance. So optimization, reducing the optimal performance of the network. As we can see the diagram, some of these examples are the routing table for the specification. We have the sinkhole attack, wormhole, and replay attack. Also the worst parent attack. And then the other class is the isolation attack. It means that one or subset of node is cut off from the rest of the network and from the root node, thus being prevented from communicating its data. We know that under RPL we have two communication. We have three communication paradigms. We have multi-point to point, that is from the sensor node to the root node, and then we have from point to multi-point, that is from the root node to the source nodes. So from the multiple point to the point, multiple point to point is called, that is the default direction of traffic, that is in an upward stream, that is traffic is moving from an upward direction from the multiple source node to the root node. And also it might be from point to multi-point. Point, that is the root, to multi-point, to the many of the source nodes that are sensor nodes that are within the network, and that is in the downward stream traffic direction. We will also have peer-to-peer, that is from one node to another node in a peer-to-peer fashion. So the aim of this isolation attack is to cut off the sensor node, the source node, so that they will not be able to send their data to the source node. Isolation type of attack have the most serious consequences, and the black hole attack is a typical example in this case. So black hole attack typically drop all the packet that the malicious node is supposed to forward. And we know that there's what we call packet forwarding in the RPL routing protocol, where we have a sensor node will select a node that has a lower rank than it to serve as its parent. Parent in the sense that whenever it has a packet to forward in the upward direction to the root node, that parent node will be responsible for relaying the packet to the root node, and that is referred to as the parent. So in a black hole attack, the parent, a malicious parent, will serve as a black hole attacker, and any of the packet that is aimed to be relayed in an upward direction up to the root node, that particular malicious parent will drop the packet so that the packet will not travel to the root node. So black hole attack combined with a rank decrease attack create a variant of the attack called sinkhole attack. So we also have a sinkhole attack. So sinkhole attack is just a variation of the black hole attack. When we have a rank decrease, a malicious black hole attacker can decrease its rank to further facilitate the black hole attack, so that more nodes will select it as its parent because it has a lower rank. So they will select it as their parent. So when it select when those sensor nodes select the malicious parent as their parent, as their preferred parent, then that malicious node will drop all the packet that the sensor node forward to the malicious parent for relaying the packet to the root node. So the malicious parent will drop the packet. That is called a sinkhole attack. So the difference between the sinkhole attack and a black hole attack is that in a sinkhole attack, another type of attack is combined with the black hole attack, and that type of attack is a rank decrease attack. We know that if the lower the rank of a node, the more it is attractive to other sensor node to select it as their preferred parent. So a node with a lower rank is usually selected by other node to serve as their preferred parent. So sinkhole attack is a combination of rank decrease attack and a black hole attack. The another variant of a black hole attack is what we call selective forwarding attack. This is a scenario where the black hole attacker will select to perform actually this selective forwarding attack is also of different types, but the one that is more common is where the selective forwarding attacker will choose the type of packet to transmit. So it is going to participate in the transpropagation of control packet. That is, the control packet that I use in this particular RPL protocol. We have the DO, DODAC information object, the DAO, the DODAC advertisement object, DAO ACK, DODAC advertisement object acknowledgement, and the DIS packet, DODAC information solicitation. So all those control packets, that particular malicious selective forwarding attacker will participate in the propagation of the control packet. But when it comes to data packet, when the sensor node send their data packet to the malicious selective forwarding attacker for it to relay the packet to the root node, then that is when the selective forwarding attacker will now drop the data packet. So it will drop data packet, but it will transmit and propagate control packet, and this make it difficult to detect. There are other varieties of selective forwarding attack which I have written a paper on, and I'm going to drop a link so that you can read the paper and see other variations of the selective forwarding attack. So this is in this figure we can see a diagrammatic representation of this black hole attack, where we have in the first figure initial network topology, where we have the malicious node. Node 5 is the malicious node, and whenever node 9, node 10, and node 11 forward their packet to the malicious parent, and that is node 5 is their parent. That is node 9, node 10, and node 11 have selected node 5 to serve as their preferred parent, so that whenever they have packet that they want to relay in an upward direction, they are going to transmit the packet to node 5, which is their preferred parent, and which happen to be malicious black hole attacking node. Then that node 5 is going to drop the packet. It's going to drop all the packet. So node 9, node 10, and 11 will never have their packet transmitted to the root node. So instead of relaying the packet to node 2, it is going to drop the packet. So this is how the malicious black hole attacking node forms works, and therefore it has isolated the node 9, node 10, and node 11 from the network. Also, node 2, if node 2 aims to send its packet in the downward direction, you can see node 2 is trying to relay packets to one of the nodes, either node 9, 10, or 11, in a downward direction. But node 5 will refuse to forward the packet to the appropriate recipient, and thereby isolating node 2 from communicating with the node 9, 10, and 11 in the network. And also this is, we have the final network topology. As we can see, node 9, node 10, and node 11 have been disconnected from the network because they can't have their packet transmitted to the root node. So Blackhole attack implementation. So in this video, we are going to be simulating the Blackhole attack. So to implement Blackhole attack, we need to perform some changes necessary in the normal source code for the RPL implementation in Contiki. So we need to locate a file under this particular directory, contiki/co/net. You can replace Contiki with Contiki 3.0 or Contiki 2.7, depending on which of the OS you are using. So Contiki co/net/IP version 6, and then there is a file called microip6.c source file, which contains the implementation of the microip TCP/IP version 6 stack for Contiki. So the file microip6.c include code that forward packets not intended for the current node to their destination. So it is the file that contain the code that make node transmit relay packet to the for other nodes that have selected it as its parent. So to implement the Blackhole attack, the malicious node should drop all such packets, and this will cause the affected node to stop receiving traffic from node with which they have no other connection. Simulation flow. So to start, for us to understand the effect of the Blackhole attack, first of all, we are going to be creating a what we call a reference simulation for the disease security attack. Our disease security attack is a Blackhole attack in this case. So we are going to create a reference simulation to observe the node's behavior under normal situation. Then when we do that, and we are going to make use of a tool called Collective View on the sync node to collect data and understand the reference behavior. So to understand how how the nodes behave in a normal scenario. Then next we are going to perform the attack simulation for the Blackhole attack, and then we are going to make use of Collective View to collect the behavior of the nodes under the attack, and then that is when we understand the effect of the Blackhole attack. So what is a Collective View? Now, a Collective View is a Java-based application in Contiki that is used for internal mode information visualization. And so we are a single mode. It will serve as our sink as normal while creating a RPL simulation RPL protocol. We have a single mode acting as a sink, receiving traffic, while the other mode are acting as traffic sources. And then we have source mode send important parameters to the sink, just which happen in a normal RPL network. So Collective View uses graphical user interface for visualizing mode parameters. In attack simulation, the tool will be used to observe the impact of malicious node on the network. So here I'm in my Contiki operating system, Contiki 3.0, and what I did is that to implement this attack, I replicate the folder. You can either Contiki or the Contiki 3.0. You can duplicate any of the folders, and then I rename it as Blackhole. So I rename it as Blackhole, and then I went to the appropriate the particular file that is responsible, that which we will modify to carry out the Blackhole attack, that is under CoreNet IP version 6, UIP6. This is it. So I enter it and make the necessary modifications that is responsible for the attack. So for the attack, UIP6. Let me see. Drop dropping packet. Alright, no, that's not the line. Let me go to that particular line of code where we make the necessary changes. Okay, sorry, I make something. UIP, go to drop. This is the line. No, this is not it. All right. Okay, this is it. No. This is it. So anyway, I'm going to make available this particular packet, this particular source file for you to get hold of it, and then all you have to do is when you duplicate the Contiki, all you have to do is come and replace the micro ip6.c and replace it with the file that I have given you, because those modifications have been made to that particular line of code that will be responsible for making sure that any node drop packet that other nodes have given to it for laying to the root node. So which is what Blackhole attack is all about. So all you have to do is just come to this particular directory and then replace this micro ip6.c with the particular file that I'm going to provide to you, and then now that any mode that is generated from this particular Contiki instance will serve as a Blackhole attacking node. Okay, so this is it. So now first thing we are going to do, we are going to simulate the reference scenario for us to see a normal RPL network, how a normal RPL network works, and then when we perform the attack, we are also going to see how the attack scenario differs from the normal scenario. So what I'm going to do, I'm going to open the terminal here. Let me zoom in and increase the font size. Zoom in, view, zoom in, view, zoom in. All right, so here we are. So what I'm going to do, I'm going to navigate to my Contiki. Okay, Contiki 3.0. Then CD tools, and then Kuja. So I'm going to the Kuja simulator. Now next I'm going to run it, sudo and run. I'm going to enter my password, user. All right, so here we are. So we have launched Contiki. Now we want to create our simulation. So simulation, let me call it a reference simulation. So reference simulation reference, or let me just name it reference, and then create. So it has created the Kuja simulation environment for us. Now the next thing, we need to add the mode. Mode is the same thing as mode. Is the same. By mode we mean the devices we are adding are the IoT devices, which have been simulated here in this particular Kuja simulator. So I'm going to come here under mode. I'm going to say add mode, create a mode type, and we usually make use of sky mode. So I'm going to select sky mode, and then I'm going to browse RPL collect. Under RPL collect, I'm going to select. Okay, so let me go to the beginning. Well, what happened is that we are going to come here under home, my Contiki 3.0. I'm going to select examples, and then I'm going to go to IP version 6, and then I'm going to go to RPL collect, and I'm going to select UDP. The first one is the sky, is the root node, so we have to select UDP sync.c. So you can see home user Contiki 3.0 examples, IP version 6, RPL collect, UDP sync.c, and then I'm going to compile it. So it has successfully compiled. Now I'm going to create just one. So also here I can go under view. I'm going to select I'm going to select mode type, so that to differentiate between the different types of mode. And then I want to show mode. I want to show transmission. Let me see, radio traffic. Okay, that was already shown, so that when we hear, you can see the transmission range. Okay, I selected something that I don't need LED. No, I don't need to show any LED light. Okay, so we have added the sync node. Now next we want to add the mode. Go to mode again. I'll add, create new mode type. I'm going to select sky mode, and then I'm going to browse. Now under that same directory RPL Collective View, this time around I'm going to select UDP sender. Let's see. So I'm going to open it. So as you can see, the home user, that's that very directory where we selected our first file. But here in this arrow, we want to select the UDP sender. That is the normal sensor nodes, and then I'm going to compile it. So successfully compiled. Next, I'm going to create, and then I'm going to select 10 modes. So add modes. So I've added 10 modes. Next, I want to add another mode of the same type as this 10 modes that I've created. But while performing the attack, I'm going to replace it with the malicious node. So I'm going to come here under mode again. I'm going to say add mode. I'm going to create new mode type. Okay. So ask, I believe sky mode 2. Okay, let me just go select sky mode, and then sky 3, and then browse. I'm going to RPL collect UDP sender.c. Open, compile, create. Just one is okay. So okay. No, I don't want it to be different, please. Let me do away with this. Let me delete it. Delete sky 12. Delete. So okay. So let me just add mode with the same as the second one that we create. As the second, just a sender mode. I want the color to be the same so that we can, when we perform the attack, we will know that this is a malicious mode. So another mode 12. They are all of the same type. Because I want to remove the last mode that I added, mode 12, I replace it with the malicious node while we are performing the attack. So this is a normal, all the modes here are normal, and they are going to run the network according to the RPL riffle. It's pronounced riffle, not RPL. Actually the name is RPL, but it is pronounced riffle. So according to the riffle default riffle behavior, where each of the node will select a node with a lower rank as its preferred parent, and that preferred parent will be responsible for relaying its children packet to the root node. So I'll make some little change to the topology. We have this is okay. I'll place some nodes. This is I'll drag my node 12 here, mode here. Okay, then let me have 4, let me have 3, let me have 3, let me have some nodes. Okay, so make sure that these nodes cannot communicate with the root node directly. So we can see that node 5 is not within the node 1 transmission range. So what we have, you can see that within these modes, only mode 12 is within the transmission range of the root node. So when node 5, node 3, node 9, and node 4 want to forward their traffic to the root node, they don't have any option than to select node 12 to serve as their parent to relay their traffic to the root node. So let me still bring them further away, but make sure they are within the transmission range of the root node. So when I click root node, you can see that they are all okay. 5 is not within now, so I can full 5, and then I have 12. Okay, so I can have 12. So we can see that they are now within the transmission range of not 12. Not 12. You can see that node 4, node 3, node 9, node 5, they are all within the transmission range of node 12, and node 12 is also within the transmission range of node 1, which is node 1 is happen to be our root node. Okay, so now I'm going to run the simulation. this is under normal behavior. So let me drag this one here, drag this one here so that we can see it properly, and then I'm going to start the simulation. This will show us mode output. Okay, sorry, I need to do something before. I need to activate the collect view. I haven't activated the collect, so let me reload this place so that I have to start the simulation from the scratch. I have to make use of collect view to collect information so that we can know the effect of the normal behavior and the behavior of the mode on the attack. So all I have to do, I'm going to come here under the root node. I'm going to select it, and I'm going to right click on it, and I'm going to go to mode tools for Sky 1, and then I'm going to select collect view. So just come up here and you can see it, mode tools for Sky 1, and then I'm going to select collect view. So the collect view has been launched. So I'm going to click on start collect. Then I'll click on this next button, send command to node. So send command to node. So I have done that. I'm going to minimize it. I'm going to minimize this one as well. Then now I can start my simulation. So we can see our simulation is going on, communication is going on between the modes. These are sensor devices. We know that wireless sensor network, sensor devices are part of IoT networks. We're running a RPL protocol, routing for low power, low C network. So these nodes are using the routing for low power, low C network. So we can see node 9, node 3, node 5, node 4. They have selected node 12 as their parent, and whenever they have traffic to forward to the root node, they have to relay it first of all to the node 12, and then the 12 will relay their traffic to the root node. So that is how the normal behavior of a RPL routing protocol works. So I've also did a video on RPL routing protocol. I'm also going to be providing you with a link that you can follow to go and learn more about this particular RPL protocol, and then when you come back to this video, you understand this better. Okay, so let's allow the simulation to run for some minutes, and then we can come back and then go and see observe the behavior of the modes under the normal RPL routing protocol. Alright, so I'm going to pause the simulation now. I'm going to pause it. Okay, so now we are going to go to the collect view and then see what data we have been able to get from this particular simulation that we run. See what we can learn about the simulation. Alright, so this is sensor data collect. So let me minimize all these windows so that we can see that proper. Alright, so here sensor data collect. So normally we can navigate through all these. We can see sensors, we can see temperature, but we are more concerned with things we are running. We are running this. Want to see especially how the power consumption is affected while running the black hole attack. So here we can see that all the nodes are present in this particular power. We can see the power consumption of all the nodes. That means that all the nodes are participating in this particular network. We can see we have 12 nodes. We have the first node is the root node. It's not here, but we have all the other sensor nodes are all here. We have the first node, node 11, node 9, node 4. We have node 2. We have node 2, Okay, we have node 3, we have node 4, we have node 5, node 6. So you can see that all the nodes are here. All the nodes are here with the exception of the root node that whose average power consumption is not normally shown by this particular under this particular panel here. So we can see everything is normal here. There's no any node that has been isolated from the network. And we see that the black hole attack is a node isolation attack. It's going to isolate them. So we are going, since they are not participated in the network, so we are not going to see their power consumption. But here we can see that all the nodes have been presented. So now when we run the black hole attack, you see that those nodes that have been attacked by the malicious black hole attacker, they are not going to be represented in this particular power consumption. We won't see anything about them, the black hole with the black hole victims that have been victimized by the malicious black hole attacking node. So that is what we are going to do next. I'm going to minimize this. Not control. So let me just minimize this. And then what we are going to do now, I'm going to go to my network. Okay, let me minimize it here, and then let me show my, which one is this? Okay, I can show this. Okay, so we have this simulation. All right, so we need this. All right, so now what I'm going to do now, I'm going to remove, or let me reload it. All right, so I'm going to remove this particular node 12, and then I'm going to replace it with the malicious black hole node. So I'm going to delete Sky 12, and then next I'm now going to add the mode, a mode from that black hole instance of Quantiki that we created. So I'm going to add modes, create new mode type, and then I'm going to select Sky mode, and then I'm going to browse, and then I'm going home. Okay, home. I'm going user, and then I'm going to black hole mode, and then I'm going to go to examples. I'm going to go to IP version 6. I'm going to RPL collect. Then I'm going to go to UDP sender.c. Let's compile it ourselves. So UDP sender.c. So I'm going to open it, and then I'm going to compile it. So it has compiled successfully, and I'm going to create it. So just one, add mode. All right, so let me observe the network topology to make sure that we maintain the previous topology that we did while running the first simulation. We see that node 4, 9, 3, 5, they are all within the transmission range of node 12. So when I look at node 12, we can see that the root node and all these other nodes are within its transmission range, but the other node, they are not within the transmission range of the root node. So they don't have any option that to select the malicious node 12 as their preferred parent. Whenever they want to forward traffic to the root node, then they have to select node 12 as their preferred parent to relay their traffic to the root node. And the malicious node 12, which is a black hole attacking node, will drop their packet. It will not forward their packet to the root node. Okay, so here we are. We can see that all those nodes, node 9, node 3, node 5, node 4, they are within the transmission range of node 12, but they are not within the transmission range of the root node. Okay, so now I'm going to go to the RPL, the collective view, and then make sure we collect the necessary behavior of the node so that we can see their behavior. So I'm going to start collect, and then send command to nodes. So we are done with this. I will minimize it, and then I'll start my simulation. All right, so I'm going to halt the simulation now so that we can go and see the effect of the malicious black hole attack on our RPL network. So here I'm going to go to my sensor data collect view. So let me minimize this so that we can see it much more better. Okay. Okay, but I need the other. Let me go on the network again. Let me show this one. Okay, so come to under power. We can see power consumption. So let's check for these nodes that are within the transmission range of the node 12. We can see node 4, node 9, node 3, node 5 are not, they have been isolated. They are not within this particular node that are represented here. Node 1, node 2, there's no node 3, there's no node 3, there's no node 4, there's no node 5, node 6, there's node 7, node 8, there's no node 9. So we can see that they have been totally isolated. We can see their power consumption within the network. And that is the effect of that is the aim of the black hole attack. So that when they have their packet to be related to the root node, node 12 will drop it. So they have not been represented in the network. So we don't have any information about them. So that means that they have not been able to communicate with the root node, because we're using this collective view is based on the root node. It is based on this particular root node. If there is any communication whatsoever with the root node, we could have been able to see their information represented under this collective view. So their packets, whenever they port their packets to be relate to the root node, then the malicious black hole node, node 12, will drop the packet. It will drop the packet. It will ensure that the packet has not been relayed to the root node. Okay, so this is black hole. This is how to implement black hole attack in RPL routing protocol using Kuja simulator. So thank you very much for watching this video tutorial, and please subscribe to my channel so that you see more of these video tutorials in the future. Thank you.